I'm going to start with your ambiguous case homework. That's the side-to-side angle or angle side-side stuff that we talked about using the law of sines. I'll move that down here. And we had to do problem 3, problem 5, and problem 9. All right, let's start with number 3. So, and the directions say to determine the number of possible triangles and then find the number of, and then find the measure of all 3 angles of the triangle, which makes sense because we need to do that to figure out the number of triangles. Okay, so I've got A, B, C, little a, little b, little c. They tell me that little a is 8, little b is 10, and the measure of angle A is 20. Okay, so to figure out anything, I have to use the law of sines. It doesn't fit the model for law of cosines. So this is going to be the sine of 20 over 8. All right, sine A over A is equal to the sine of B over B, which is 10. And then I can go ahead and cross multiply. So 10 times the sine of 20 will equal 8 times the sine of B. Then I'm going to divide both sides by 8. All right, notice I haven't put anything in my calculator yet. I'm waiting till the very last possible moment. So now I'm going to put stuff in my calculator. So 10 times the sine of 20, and then I'm going to divide by 8. You should get about 0.4275, blah, blah, blah. All right. 0.4275 is not what you're going to put in your calculator to do the inverse sine. You're going to do inverse sine and then copy. Hit second and then the negative button. That'll copy the answer. And you should get that B is equal to 25 degrees. Okay? And if B is 25 degrees, that means that C is going to have to equal 180 minus 25 minus 20, which will give me 135. All right, so that's one legit triangle. But remember, sine is also positive in quadrant 2. So I need to figure out my quadrant 2 possibility. So I'll put a little squiggle down here. All right, my quadrant 2 possibility is going to be 180 minus 25, right? 25 is my reference angle. So that is going to give me that B is 155. And if B is 155, then C is going to be 5 degrees. All right, it's a very small angle, but it's legit. All of them are positive. So the first way worked in the purple, the second way worked in the black. So the final answer is that there are 2 triangles. And then you need to, have all this work shown. Alrighty. Now to do number 5. Scroll up so I can read it. So my triangle. So here they tell me that little b is 12, little c is 10, and the measure of angle B is 49. All right, I don't have 2 sides in the included angle, so I have to use the law of sines. So I'll do the sine of 49 over 12, all right, the sine of B over B, is equal to the sine of C over C, which is 10. And then I can cross multiply. So 10 times the sine of 49 will equal 12 times the sine of C. A little bit. Divide both sides by 12. So sine of C, when you put this in your calculator, 10 times the sine of 49 divided by 12, you should get about 0.6289, blah, 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 blah. All right, so go ahead, do inverse sine, hit second and the negative button so it copies your answer, and you get that C is E. What happened? C is about 39 degrees because it says to the nearest degree. Well, that means that I can go ahead and find A. All right, because that's going to be 180 minus 39 minus the 49 that the problem told me for B, and you get 92. So that's my first possible triangle. But since sine is positive, I also have to check my quadrant 2. When I check quadrant 2, C is going to be equal to 180 minus 39, which will give me 141. I don't know why my board is sticking out. 141. So A would have to be 180 minus 141 minus 49. A would have to be negative 10 degrees, which is not humanly possible. So we reject this. All right. So the final answer is that there's only one possible triangle. All right. You have to show doing the second case, so you actually have some work to justify why you're saying 1 or 2 triangles or none. All right. Moving on to number 9, I'm going to squeeze it in on the side. All right. I'll make my triangle. Here's A, B, C. They tell me that AB is 14, BC is 21, and angle C is 75. All right, you have to use the law of sines. It doesn't fit the law of cosines. So the sine of 75 over 14, so the sine of C over C, is going to be equal to the sine of A over 21. So cross multiply, 21 times the sine of 75 will equal 14 times the sine of A. Divide both sides by 14. Put this into your calculator. 21 times the sine of 75 divided by 14. You should get about 1.4488 blah blah blah. All right, and hopefully you're noticing there's a red flag going up because right now I've got sine being bigger than 1. All right, remember sine is bounded by 1 and negative 1. All right, I can't be bigger than 1. I can't be lower than negative 1. And if you put this in your calculator, inverse sine, you're going to get an error. All right, so this can never happen. And since this can never happen, there's not going to be a reference angle ever happening. So there are 0 possible triangles. There are no triangles in the world that can have AB being 14, BC being 21, and an angle C being equal to 75. All right? That's nice. We have 1 each. Moving on. We also had to do some imaginary number work. All right, we had to do a little bit more on this one. We had to do 3 through 10. Oh my goodness, I'm so mean. We had to do all of those. We also had to do 19 through 22. Oh my goodness, again, I'm so mean. And 35 and 36. All right, so let's start. But 3 through 10 are super easy. All right, for 3, I've got the square root of -4. Which we can write as the square root of -1 times the square root of 4. So this is going to be I times 2, or 2I. Easy. I'm pretty sure we did that one in class. Number 4, square root of -81. That's the square root of -1 times the square root of 81, which will give you 9I. All right, and if you don't want to write, all of this work, if you just see it as, oh, number 3 is 2I, number 4 is 9I. Go for it. All right? Don't write it if you don't have to. Number 5, the square root of -9. It's the square root of -1 times the square root of +9. So that will give you 3I. Number 6, negative the square root of -36. All right, remember I said sometimes they throw in these random negatives on the outside. Okay, so that's going to be -I times 6, or most normal people would write that as -6I. So we do still have a negative in that answer. Number 7, they do the same thing. Negative the square root of -121. That's negative the square root of -1 times the square root of +121, which is going to be a -I times 11, or -11I. Number 8, square root of -8. So that's the square root of -1 times the square root of 8. Now, 8 is not a perfect square, so it's not like, the square root of 4, which just gives you 2, but we do know how to break 8 down, right? Maybe a little flashback. Okay, so this is going to be I times 2 square root of 2, which we usually write the numbers in front of the letters. So 2I times the square root of 2. Alrighty. Move it down a little bit. That was 8. We have to do 9. 9 is the square root of negative 12. Very similar to how we just did 8. That's negative 1. That's positive 12. So that will give me I. And when you break down 12, that's 2 times 2 times 3. So that's going to be 2 radical 3. So that would be 2I square root of 3. And last but certainly not least, number 10. 10 has negative the square root of negative 72. So that's a negative, negative 1, 72. So carry down the negative. The square root of negative 1 is I. 72, I'm having a moment. Can't really remember how that breaks down. 72 is 9 times 8. Okay. 4, 2, 2, 2. So I'm going to pull out a 3 and I'm going to pull out a 2. So that's 3 times 2. And I've got a 2 that's still stuck in there. So that's going to be negative 6I square root of 2. Alright? So besides the I part for the negative, it's the same breaking down of radicals that we've been doing. Alright, I'm going to erase this just so I can keep everything together, the book work and my work. Whew, not that bad, okay. Alright, number 19, also very similar to what we did in class. Square root of negative 100 plus the square root of negative 81. That's negative 1 and positive 100. That's negative 1 and positive 81. So that's going to be 10I plus 9I. And 10I plus 9I is just 19I. 20 square root of negative 25 minus the square root of negative 4. That is going to be, you can break it down. And if you don't want to break it down, you don't have to, but for a lot of people it helps. So that will give me 3I. 21. So that's going to be negative 1, positive 144. This one is probably going to look kind of silly. Well, actually, this one is kind of silly because I know the square root of negative 1. That is the definition of I. So I'll just change that right off the bat. So that's going to be 12I plus I. So 13I. I feel like a pirate. And 22, square root negative 49 minus square root negative 16. So that's going to be 7I minus 4I, which is 3I. Alright? Easy peasy. Lemon squeezy. And last but not least, we also had to do 35 and 36. They got a little discombobulated when I copy and pasted, but I think I can still make them out. 35 gives us 3I plus 2I cubed. Okay, now looking at 3I, I is just I. Okay, but remember, my I1, and the middles are negative. So this is I to the first, that's I squared, that's I cubed, that's I to the fourth. So I can replace I cubed with negative I. So this is going to be 3I plus 2 times negative I. And 3I minus 2I is just I. Very similar to how we are going to do 36. 36 gives us 5. What am I doing? I wrote a T. Whew. 36 gives me 5I squared plus 2 I to the 4th. Coming over here, got my square. Coming over here, I know that I squared is really equal to -1. So this is really 5 times -1. And I know that I to the 4th is really 1. So this is actually 2 times 1. So that's -5 plus 2, so -3. Alrighty, and that was it. That was all your homework was.